Now, this week we're going to take a look at Chapter 2 in the book, parts of it anyway, and then, of course, read it and be part of that also. And oh, there it is. Okay, so last week we had the snow day, but that was over Chapter 1. So if you haven't read Chapter 1, be sure to read it. There's a lot of good information in there. Chapter 2 goes right along with the project that'll be for this week. It'll be a programming test. And I'll be talking more about that as the class goes on. Okay. So this is operators and statements. Use Java operators, including parentheses, override operator precedence, create if and if else, and ternary constructs. Use a switch statement. Create and use while loops, create and use for loops, including an enhanced for loop, create and use the do while loop, compare loop constructs, use break and continue. I'm going to focus on the if, the for, and the while loop with an example. And the example I'm going to give you will be very close to what you're going to do on the test. And we've already been using some of these, so these like aren't brand new constructs that we're looking at. Okay. Start a new project. I guess that name is as good as any. Part of our accreditation is the Higher Learning Commission requires us to assess our own program outcomes. They want us to look at our results and see how we're doing. And based upon the results, then make improvements. Very simple concept. So with the program outcomes, then what I do from the programming standpoint is I test your ability to create a while loop, a for loop, and an if else structure. And they're not really hard ones because, well, in reality, those aren't really hard constructs to compile and to grade. Okay, so okay, so from our source packages, I guess I could just probably expand it all there, but I just want to show everything. From our source packages, we got this package right here, this default, and again, it always comes up with our default name, Cali dot, and then whatever the name of the project was. And if you add your items here, it'll put it in that package. Packages share certain aspects, so that's why it's beneficial to put them in the same package. We really haven't looked at that very close. But I right-clicked, I did a file, or right-clicked, did a new JFrame form. There it is. Main form. Now we're gonna last week. Let's see here. Last week I had you program a rectangle class. We're not ignoring classes from here on out. We're going to go back to it, but we're going to temporarily go away from that. Although I could probably design something to use as a class and build on that. Now, if you look at source code here, in Java, everything we're working on is a class. We've been using them all along. We're just not directly creating our own brand new one over here. Okay, so I want to bring in a couple of text boxes, text fields. my goal is I want to multiply the numbers from this one to this one, and then put the answer somewhere. Okay, so let me put a label there. Label here. And I think what to call that. Edit text. Right click, change variable name, TF num1. Right click, edit text, backspace, enter. This one, a right click and choose change variable name and TF underscore num2. And right click on these, change edit text, 1. Right click on add edit text, num2. I want a button. And right click on that, change edit text, and have it say calculate. Okay, grab a drink here. And drop a label here, label here, label here, label here, and some more. I'm going to click up here with my left mouse button and drag and draw a rectangle around all those. And change the font of those to 15 so I can see them a little bit easier, or 14. Maybe 18. Excuse me. Okay, so this is going to be my my product. Right click on that to say edit text, product, and this will be via the for loop. Sorry. This one, right click on that, say edit text, product, while loop. Right click on this one, say edit text, and if, else, results. Okay, so I'll be putting my answer in here, so I'm going to rename these. Change variable name, I'll call this LB underscore answer 1. Right click on that, change variable name, LB answer 2. Right click, change variable name, LB answer 3. Now drag and highlight all those, right click, edit text. Oh, let me do edit text. That's interesting. Come over here. Well, that really shrinks down when you do it over there. And do Control Z. There. Right click, edit text. What is going on there? Backspace. Yeah. Let's see about making them invisible. What's the property called? Focus. You get very other language except for what to use here. I don't see it. Focusable, enabled. Okay, well, 2, 3, 4, 5. Throw some spaces in there. And text 1, 2, 3, 4, 5. And text 1, 2, 3, 4, 5. There we go. Good enough. Well, more than one way around that. So that just puzzles me. There isn't a visible. Enabled should be such I can't click on it or do anything with it. Focus should set the focus to it. So what in the world is, let's see. It means visible property. Visible property is hidden for swing components. Usually they make it hidden. That means something's replaced it. Interesting. Oh well, I couldn't worry about that. Doesn't have anything to do with what I'm doing. Okay, so right click on this one, choose events, mouse clicked. Okay, I'm just gonna work with integers. Let's make it a little bit easier. Num1, num2, the product. Guess that's good for now. I need to bring in those values. So we'll say num1 is equal to parse. Pretty sure it's parseInt. I just use parseInt in Android Studio, which is Java. And then my tf underscore num1 dot get text or text. Get text. What's that return? That returns a string, so I should not have to change that to a string. Num2 is equal to integer dot parseInt tf underscore num2 dot get text. Okay, so then my for loop for the product. On the test, I'll ask you 3 items. I'll ask you to add all the numbers between 2 numbers. Like add all the numbers between 5 and 70, for example. And so I want you to, on your code, I want you to create blanks where you can put those in. And you'll turn in not only the answer, but you'll turn in the code. So that's very important because I grade both of them. If you leave one of those off, you'll miss points. The code actually gives me an idea of how's people's coding skills. You know, is it horrendous how they did it? For example, to add numbers together, I could say num1 is equal 30 plus 31 plus 32 plus 33 plus 34, all the way up to whatever I put in there. And it may seem tedious, but that would work. That is not what I'm looking for. So the answer is not the important part. I want to look see how you designed it, your code. Okay, so I have 4 int x equals 1, I guess. X is less than, not 1, num1. That's the first number I brought in. And continue y, x is less than or equal to num2. So that's my largest number I want to go to. And then I want to increase this by 1. So I'll go ahead and do a plus plus, or you can do x equals x plus 1. Now I need to initialize the product initially. The product is equal to 1. And then down here, I'm going to say the product is equal to the product times x. And then I'll write my answer back out. TV1, no, LB1, LB underscore answer 1 dot set text or text set text. And I think this is string dot value of, we'll see, the product. So make sure this works, and then I'll go back and explain it. Okay, 3, 5 gives us 60. Okay, so let's go with our example of 3 and 5 and walk through the code. I know you've seen for loops already, but I just want to make sure everybody understands it. The randomization library is nice in Java. You can find some random numbers. Somebody did that in one of their projects where they didn't have to. It was very nicely done. But the core pieces of programming you should know is the for, the while, and if. Knowing those other items are important, but very, very minimum you should get out of any programming class, any beginning programming class, is those knowledge of those 3 items. If you're not, that means I'm not assigning enough projects on those. Okay, so we got num1, num2. Now I entered an example of 3 and 5. Okay, so we got the product is equal to 1. That's equal to 1 right here. Then it comes down here, and temporarily it defines x. Since int x is within my for loop, it only exists while that for loop's running. After that for loop gets done running, the x is no longer available. But it initializes that to num1. Now these are all stored out in memory, so keep that in mind. It immediately checks to see if x is less than or equal to num2. 3 is less than or equal to 5, so that's true. So then it'll go down, it'll do line 153. The product is equal to the product times x. So it takes the old value of the product, which is 1, times the current value of x, which is 3. 1 times 3 is 3, and then it writes that back out to the product. Then comes up, immediately does this x plus plus. So that increases that by 1. So that goes to 4. It then goes back and checks this. It says, hey, is 4 less than or equal to num2, which is 5? 4 is less than or equal to 5. That's true. So it does line 153 again. Goes and gets the old value of the product, which is 3, times the current value of x. 3 times 4 is 12, and writes it back out to the product. Goes, does the x plus plus again. So that increases that to 5. It then checks x is less than or equal to num2. See if that's true. 5 is less than or equal to 5. It's not less than, but it's equal to. So it goes down, does 153 again. Takes the old value of product, which is 12, times current value of x, which is 5. 12 times 5 is 60. And writes that back out here. Does the x plus plus again. Changes that to 6. And then it checks whether x is less than or equal to num2, and 6 is not less than or equal to 5. So that's false, so it goes, kicks down and does line 154. And writes out 60. Okay, the while loop for the product. Have a drink here. We can reuse the product. I'll set that equal to 1. I'm going to declare a variable called x and set it equal to num1. Now I might look at that and say, whoa, you used x right here. How can you use it again? Again, this int x within my for loop just defines it for the duration of the for loop. Does not exist outside of that scope. And so when it's done, I can freely use x again. I can declare it down there. You know, the one thing I never have tried, just try that, see how it gives me red squiggly. It says it's already defined. Question is, what if I put curly braces here? By putting curly braces, that means that this only is defined for the existence of these curly braces. So that's why I can declare it here. I was curious. Okay. Got that. That's my initialization. That's the same thing as the for loop does right here. Initializes it. Now I'm going to have my while statement. I'm going to say while x is less than or equal to num2. You notice that that Boolean condition matches the Boolean check up here in our for loop. Okay, put curly, beginning curly brace, closing curly brace. Now immediately I want to increment x, so x is equal to x plus 1. Or I could do x plus plus, as in the for loop up here. And then this will be the product equals to the product times x. And once that's all done running, I want to write it out to my LB answer2 dot set text. String dot value of the product. Let's run that. Three and 5. Got something wrong. The prod cut. The product. That's weird. Okay. When I say it's weird, it's not weird that I had an error. I have errors all the time. That's just normal. If you're a programmer, unless you're a robot, you're going to be writing error-filled code, and you have to figure out what's going on wrong with it. The weird part of it is that it went ahead and ran it anyway, even though I hadn't declared prod cut. I would have expected the NetBeans IDE to stop it and say, hey, well, wait a minute, you can't do that. Obviously, I'm wrong. Okay. Then, last thing. Some gun test is an if-else loop, if else. So we're going to check the product we just came up with and see, we're going to compare to see if it's, what did I do on the other class? I think I checked to see if it's greater than 100 or something like that. So if the product is greater than 100, then I'll be LB answer 3 dot set text greater than 100. Else, if it's not greater than 100, must be less than or equal to 100. There you go. And what I'm going to guide you to do is not much more complex than that. I might have you bring something in from the form, and then you just compare the value. Those of you who have taken the programming test before, you know it's not horrible. It's not meant to be. Okay, it gave us 120, which is greater than 100, so compare to that. Let's take it back to 3 and 5. This gave us 60, which is less than or equal to 100. So that shows the for loop, while loop, and if else. It is a time test, so I'll give you plenty of time. If you recreate the code I just did here first, verbatim, just like you see me do it. Then when you get ready to do the test, all you have to do is probably make minor changes to your code. You're going to probably be done in 10 or 15 minutes. Shouldn't be real horrible. You do have to think about what do you have to change over here where I said the product equal to 1. You have to think about what do you have to set it equal to for your purposes when you're summing numbers. Okay, let's see what else is in the book now, because that's what I wanted to cover in terms of the test. Java operators, we talked about the plus plus increases it, minus minus. If you put the plus plus minus before, it's mainly when does it do it type of check. That has more to do with if you're writing code like this. I don't know if I even know how to do it. The product. Like that right there. You know, what would this do exactly? I think it would set the product equal to product and then increase product by 1. Versus this form right here, I believe, putting the plus plus before it, I believe increases product by 1 and then assigns it to the product. So, but that's the only thing real tricky about some of those. Excuse me. Work with the arithmetic operators. Oh, one thing to notice here. 9 divided by 3 gives you 3. 9% 3 outputs 0. The percent is your modulus. That's the remainder. When you do an old school division, way back when, 9 divided by 3 is 3 with the remainder of 0. So that's what that gives. Numeric promotion. This is kind of an interesting concept. Now that you understand basics of arithmetic operators, it is vital we talk about primitive numeric promotion. Java may do things that seem unusual to you at first. Okay. So for example, int I1 double D1, I1 is equal to 3, D1 is equal to I1. Now that would take my value of 3 and assign it to a double, which it handles that just fine because an integer is a type of double. So okay, can do that. D1 is equal to 3.1. You said I1 is equal to D1. Notice it says incompatible types, possible lossy conversion from double to integer. Okay. Now this right here is a double, has decimals, and we're trying to assign it to an integer which doesn't have decimals. So what happens with the 0.1? Does it round? Does it drop it? Some languages allow you to do this, by the way, and then it handles it appropriately. This is giving us an error. Now let's say if I get rid of the 0.1, it still says, hey, possible lossy conversion from double to integer. So you'll find that some of your numeric promotion rules you can do just fine. Two values have different data types. Java will automatically promote one of the values to the larger of the two data types. If one of the values is integral and the other is floating point, Java will automatically promote the integral value to the floating point value's data type. We looked at that. You can take an integer and assign it to a double or a float or whatever. Smaller data types, namely byte, short, and character, are first promoted to integer anytime they're used with a Java binary arithmetic operator, even if neither operands is integer. After all promotion has occurred and the operands have the same data type, the resulting value will have the same data type as its promoted operands. Sometimes this catches you. This it trying to figure out what things should be. Like this right here. Double D1 is equal to 1 divided by 3. Let's write that out. LB answer 3 dot set text string dot value of D1 So I need something here so it won't break. I get 0.00. Why is that? 1 is an integer. 3 is an integer. So it's saying, okay, 1 divided by 3, I'm dividing integer by an integer, which I should put it back to an integer because they're both integers. So it doesn't try to promote it, change the data type at all. If, in this example, you put in a 1.0 here and run that, you notice that we get what we'd expect. 1 divided by 3 should be a bunch of 3s. This, since one of them is a floating point or a double, it will promote it, the calculation itself, to a double, and that's why you get the results you do. It's really easy to change. If you ever have that happen, you just put that. We do a cast too. I'm trying to remember how to do it in Java. I think that's right. So that still work that way. This is referred to casting. It's where you're changing one data type to another data type, where possible. And you put a double in front of it with parentheses around it, then it'll take that and convert that to a double. Now notice we got a 1 here, and it says that, hey, string cannot be converted to a double. Casting does not work across all the data types. That's why we had D1 is equal to double dot parse double 1 divided by 3. So if you want to convert a string to a double, then this is the way to do it. Don't ask me why. I didn't design the Java language. Seems like to me it'd be easier just to allow you to just do that, but they didn't. Anyway, this is going to go into a lot of that, but that's something you have to consider because you can get just bizarre results by the mixing of data types. Unary operators, talked a little bit about these, plus, minus, minus, increments, decrements, plus and minus. Can be considered a negative or negates an expression. Positive. Here's a not x. Here's a negative. Now I've gotten so used to this, I couldn't even tell you Java has this. I won't remember tomorrow. But a lot of programming languages do not allow you to put a dash before a variable like that. You have to take -1 times the variable. And I've gotten so used to that I probably can never break myself and start doing it with Java. So like here, I got 3, and that's equal to -A1. See how it negated it? Versus equals -1 times A1. So gives you the same result. Like I say, I've gotten so used to putting a -1 times since some languages don't support it. Okay, talks about increment and decrement. Assignment operators we've already been referring to. Here's a casting I was talking about. This is interesting. Overflow and underflow. Expression of the previous example not compile those costs. The second value is too large to be stored as a short, so numerical overflow occurs and becomes 20,678. Overflow is when a number is so large it will no longer fit within a data type. So the system wraps around to the next lowest value and counts up from there. Or it could be an underflow where number's too low. Anyway, just something to keep in mind when you're programming. Think about the largest value you're going to have, and then handle that appropriately. Don't assume you want to make everything double just so your variable will take whatever number size. Well, double has its limits too. Good programming means you don't use the data type that's larger than necessary. Actually got a class. I had students tell me, but I never have programmed it myself. I'm not even sure how you do it, to be honest. But at Wichita State, they have a programming project in one of the classes where you had to program a big integer times a big integer using arrays. You couldn't use the asterisk for multiplication. And the idea on it is, I'm kind of think about, I might know how to do that now. It's a series of for loops. Still be challenging for me. It'd take me a while. I couldn't sit down here. Let me do it in 10 minutes here. No, that's probably more like an hour or 2 hours to figure it all out. But the idea is on it is that how do you handle it programming wise if you do need to multiply two numbers together that are bigger than what data type allows? And so that's what that's there for. Here's the and, the or, exclusive or. Those are sometimes handy. Like if program something, it only does it when both of them are true or when this or this is true. Exclusive or is true when they're both different. One's true and one's false. Equality operators. Okay, we just talk about the if then. We've used it before now anyway. Okay, I guess that's about where I wanted to get to. So there won't be any project out of this for this week because there's the programming test, which is programming. So you have to program a project anyway, and I want you to paste the code in and the answer. Make sure you put both or you miss points. The programming test is to provide both of those. But we'll go ahead and stop there.